we have verified the routing tables of the head office firewall and then branch office firewall. Now, if you see ISP R1 router, we'll have a routing table. Because it has an IP address of 20.2, a route will be there saying that for 20 area yourself can send the packet. It has an IP address of 30 network ID. You'll also have a route saying that for 30 network ID also yourself can send the packet. It does routes for 20 and 30 because these two are what? Directly connected. It also has route for 40 network ID saying pass on the packet whom now 30.2. If you see in the topology diagram here, 20 network ID, 30 network ID, and 40 network ID. These three are what? Public IP addresses, public network IDs. So ISP routers should know routes for all the three network IDs 20, 30, 40. So we had a route on R1 router saying for 40 area, pass on to whom now? Next hop router 30.0.0.2. Similarly, if I see routing table of ISP R2 router, it has routes for 30 area because it is directly connected. It has route for 40 area because it also what? This directly connected. And we had a route saying that for 20.0.0.0, pass on the packet to whom? 30.0.0.1. So these routes are there in the routing table of ISP R1 router and ISP R2 router, right? Now let's see. So we have verified the routing tables of head office firewall, branch office firewall, ISP router 1 and ISP R2 router. Now, from this particular system here, somebody says ping 192.168.21.10 means what? Somebody sitting on this particular system would like to ping, would like to send a packet home 21.10. Who is 192.168.21.10? This particular system in the branch office. So system in the head office would like to communicate with the system in the branch office, right? Now what happens? Let's see as to what happens behind the scenes. The packet will be sent to whom now? The comes to the firewall here. Seeing the two address, the packet will go to this particular layer 3 switch. Layer 3 switch will forward the packet to the head office firewall. What happens on head office firewall here? The IP protocol running on the virtual router here, we'll see what? We'll see the two IP address in the cover. What's the two IP address? 192.168.21.10. So IP protocol here understands the packet is not meant for it. It has to do what? IP forwarding should forward the packet, right? To whom should it forward the packet? 192.168.21.10 means what? 10 hosts in 20 this area now. So IP protocols is routing table to see route is available for 192.168.21.0 network ID. There is no specific route available for 192.168.21.0 network ID. So which route will be applied by the router here now? It applies a default route. And default route says what? Any network, any mask. If you don't know the route, simply forward the packet to whom? 20.0.0.2. And who's 20.2? ISP R1 router. So the packet will be forwarded to the ISP R1 router. Now what happens in ISP R1 router again? The IP protocol running on ISP R1 router will again look into the two IP address in the cover. What is the two IP address here? 192.168.21.10. So what happens now? IP again should forward the packet. Again, IP protocols is a routing table. Is there any route for 192.168.21 network ID? No route. Why no route is there? Because it is what? A private IP address. Because it is a private IP address, on the ISP routers, routing is not defined for the private IP addresses. What happens now? the IP protocol here drops the packet. So ISP R1 router drops the packet because there's no route in the routing table for this particular IP address, right? So the packet will be what? Dropped. That means when the packets are going for 122.10, also the packet will come to the firewall. Will forward the place a default route forwards to whom? ISP R1 router. ISP R1 again sees routing, the row route is there. It drops the packet. Again, if I try to send a packet to 23.10, some system in the branch office here, again the packet comes to the firewall. Firewall will forward the packet to applying the default route. It forwards the packet to whom? ISP R1 router. ISP R1 router drops the packet because it doesn't have route in the routing table for this called a private IP address. Means when the packets are going from the head office, going to whom? Either 192.168.21.0/24 or 192.168.22.0/24 or 192.168.23.0/24 means what? Packets are going to whom now? Branch office. When the packets are going to the branch office, the ISP routers drop the packet because they don't have route in the routing table for this particular private IP addresses. Right? So that is a problem. Now, let's see what happens on the branch office side now. Somebody sitting on this particular system here, they send what? Sending a packet to 11.10. Means what? Somebody is trying to send a packet from this particular system to this particular system in the head office. Then what happens? The packet again, the to address will be 11.10. From address will be what? 21.10. The packet comes to the firewall here. What does the firewall do? The IP protocol running on the firewall will look into the to IP address. What's the to IP address here now? 192.168.11.10. So the packet has to go to whom now? 10 host in 11 area. So IP protocol sees a routing table. Is there any specific route for this area? No. It applies what? The default route. Default route says send the packet whom? 40.0.0.1. So the packet will be forwarded to whom? ISP R2 router. Again, the IP protocol running on ISP R2 router sees into the cover now. What's the two IP address over there? 192.168.11.10. The packet has to go to whom now? 10 host in 11 area. IP against this routing table. Is there any route for this area now? No route. Why? Because it is a private IP address. So again, what does this router do now? It drops a packet because it doesn't have route in routing table for 192.168.11 network ID because it is what? A private IP address. The packet will be what? Dropped. Similarly, if somebody says ping 192.168.12.10, again, what happens? The packet will come till the branch office firewall. What happens over there? It sees the to IP address. Applies a default route, sends a packet to ISP R2 router. Again, ISP R2 router again sees drops the packet because it doesn't have route in the routing table for 192.168.12 network. Again, if I try to send a packet to 13.10, 192.13.10, again the packet goes to the firewall. Firewall applies a default route, forwards the packet to ISP R2 router. The IP protocol again is a to address. It's a private IP. No route is routing table. It drops the packet, right? That means from the branch office, when the packets are going to 192.168.11.0 or 192.168.12.0 or 192.168.13.0 means the packets are going to head office network. The packets will be dropped by the ISP routers because they don't have route in the routing table for this particular private IP addresses. Right? So we have seen that if at all you want to make two different private network IDs, communicate with each other through the public network ID, we create something called as GRE tunnels, right? So let us see how to do that on the head office firewall. Now see here now, on the head office firewall, we create something called as tunnel interface. Let's say we create tunnel.1 interface. Somebody on the head office system here, they say ping 192.168.21.10. The packet will come to whom now? The head office firewall. The IP protocol sees the two IP address. What's the two IP address? 192.168.21.10. So the packet should be forwarded to whom? .10 system located in 192.168.21.0 network ID. So IP protocol sees the routing table. What do I do in the routing table? I add a route saying for 192.168.21.0, send the packet via tunnel1 interface, tunnel.1 interface, right? We add a route like this. Now the packet has to go via whom now? The tunnel1 interface. Send via tunnel1 interface means what? Send via tunnel1 means add one more IP cover. Correct? So it will add one more IP cover now. In the new IP cover, what will be the source IP address? When I add a new IP, I should add the source IP to IP. What will be the source IP address? In the new cover, add the source address as 20.1. Destination address as what? 40.2. Who's 20.1? Your own IP address as source IP. And the two IP address as what? IP address of the branch office routers, public IP address. Right? So that's what they mean. Sending via tunnel.1. Send via tunnel.1 means add one more IP cover. In the new IP cover, add your own IP address as source IP address and the IP address of the other firewall as branch office firewall as what? Destination IP address in the cover. That's what is meant by sending via tunnel.1 interface. So now what happens now? It will add the source address as 20.1, two address was what? 40.2, and then try to send the packet. Now again, IP protocol sees a two address, 40 sends a packet ISP router and the packet goes, right? Similarly, when somebody sends a packet 22.10, also when the packet are for 23.10, what should I do? For all the network IDs in the branch office, be it 21.0 or 22.0 or 23.0, we say what? Send via tunnel.1 interface. How do I do that? We do that in the routing table. Right? We add routes in the routing table saying for all the three network IDs 21.0, 22.0, 23.0, send via whom now? Send via tunnel.1 interface. Send via tunnel.1. Send via tunnel.1 means what? Add a new IP cover, one more IP cover. In that, add the source address as 20.1, your own IP. Two address as what? 40.2, the IP address of the other firewall. But then before I could add the routes in the routing table like this, the tunnel.1 interface should find a place in the routing table. How do I do that? We make sure that tunnel.1 also has an IP address configured for it. And tunnel.1 should also be belonging to some zone in the firewall. So let us keep tunnel.1 also in external zone. I would like to keep Ethernet 1/2 and tunnel.1 both in external zone. I could have kept in some other zone also, but I prefer doing like this. Both of them I keep in what? External zone like this, right? So let us do this configuration on the Palo Alto firewall. So now I go to the lab setup here. This firewall here, Mango head office firewall. And there I go to networks. I go to network. I go to interfaces, right? So where am I now? On the head office firewall, I go to network, I go to interfaces. There I go to tunnel interface. Let us get the tunnel interface first of all now. I go to tunnel interface. I'm adding a new tunnel interface. I say add. I get one tunnel interface called as what? Tunnel.1. Tunnel.1 as shown in the diagram. If you see the diagram here, I'm creating what? Tunnel.1 interface. And I also attach it to the virtual router called as VR1. And also I assign it to the security zone called as external. As shown in the diagram. If you see the diagram here, I created one tunnel.1 interface, assigned it to the virtual router VR1, and also I'm assigning it to what? The zone called as external zone, right? And also I need to give it an IP address as 192.1.1/16 now. Let us see that. So I go here, I go to IPv4 here. I say add. I'm giving the IP address as 10.1.0.1/16. Now I say what? 10.1.0.1/16. I say enter. I say okay. So we created one tunnel.1 interface, assigned IP address as 10.1.0.1, assigned it virtual router VR1 and also external zone, right? So see the diagram here, the case study here, lab setup, tunnel.1, IP address is 10.1.0.1, assigned to virtual router VR1, kept in what? Security zone called the external. We do that first. Now I go to the virtual routers. I go to firewall one, VR1 virtual router. Then I go to the static routes. So let us add all the three static routes as shown in the diagram. For 111.0/24 send via the tunnel.1. Sorry. For 21.0 send via tunnel. Let us add all the three static routes in the routing table. So I go here, I go to static routes. I say add. I'm adding a route here. Let's give the name as 192.168.21.0. I say 192.168.21.0/24. Send the packet via the interface Ethernet. Sorry, via Ethernet, via tunnel.1 interface, right? 21.0. I made a mistake here. Let's give it as 21.0. Right? So next hop address say what? None. I don't mention the next hop IP address. So I'm adding saying that for 21.0, send the packet via tunnel.1 interface. Now I say what? Okay. Similarly, I add one more route saying for 192.168.22.0, 192.168.22.0/24, send via tunnel.1 interface. Next stop is what? I say none. I say okay. Similarly, add another route for 192.168.23.0, 192.168.23.0/24, send via tunnel.1 interface. Next stop is what? I say what? None. I say okay. So we added all the three static routes like this. Now I say what? Okay. Now I go to again network. I go to GRE tunnel. GRE tunnel. There I add a new GRE tunnel saying HO-2-BO, head office to branch office. I just give some name. Interface, send via the Ethernet 1/2 interface. Local IP address is 20.1. Peer IP address is 40.0.0.2. And tunnel interface is tunnel.1. Now let's understand as to what is the meaning of this particular dialog box now. See now, send via tunnel.1 means what? Send via tunnel.1 means add one more IP cover. The new IP cover source address should be what? 20.1. To address should be what? 40.1. That's what I mean by the. If you see the diagram here, sending via tunnel.1 means what? Add one more IP cover. The new IP cover add the source address as what? 20.1. To address as what? 40.2. Source address should be what? IP address of Ethernet 1/2, 20.1. To address is what? 40.2. That's what I mean. Right? So that's how I create the GRE tunnel. Send via tunnel.1 means add one more IP cover. The new IP cover, add the source address as 20 dot, which is the IP address Ethernet 1/2. Two address should be what? 40.2. That's what I mean by this particular dialog box. In Cisco routers, we give the command tunnel source, tunnel destination, right? Here we fill up the dialog box like this. I say now, okay. Now I say commit the changes. Commit the changes. I say commit. If you see the diagram here, because we give the IP address for tunnel.1, one more route will get added saying for so-and-so network ID, send the packet via tunnel.1, right? Now let us verify the routing table now. So I go to the lab setup, I go to activities, I go to HO firewall, I go to HO firewall. There I give the command admin. I say capital P at the rate of SSW0RD. I say enter. I give the command show routing route. When I give the command show routing route, it shows like this. Let us verify routing table now. If you see the diagram, this particular route should have got added saying that for 10.1 send via tunnel.1. If you see here, it says what? For 10.1/16, send the packet via whom now? Tunnel.1, because it's directly connected. Then we added these static routes saying what? For 21, 22, 23, send the packet via tunnel.1 interface, right? Same thing you see in the diagram also here. For 21, 22, 23, send the packet via tunnel.1 interface. So like that, these static routes are added in the routing table. Fine. Now I also go to the firewall again. I go to the policies, head office firewall. I add a new security policy called as P1 policy. Policy P1 saying when the packets are going from zone 1, sorry, internal zone or external zone, go into again any system coming via internal or external zone. For any application, any service, allow the packets to go. I say what? Okay. Now I say commit the changes. The changes will be committed onto the firewall. Similarly, let us see how to configure the branch office firewall with the GRE tunnels. Now, if I go to the branch office, again on the branch office firewall also, we create what? One tunnel.1 interface. And then and somebody says ping 11.10 from this particular system, the packet comes here. We should say what? Sees the two address as 11.10. So there should be a route saying for 192.160.11.0 send via whom now? .1 tunnel.1 interface, right? Sending via tunnel.1 means what? Send via tunnel.1 means add one more IP cover. The new IP cover, what should be the source IP to IP, right? The source IP should be what? 40.2, its own IP address. The two address should be what? 20.1. So source IP should be 40.2, two address should be what? 20.1. Again, if somebody says 12.10 also or 13.10 also, the packets are going for 11, 12 or 13 network IDs of the head office. All of them should send the packet via whom now? Tunnel.1. So I should add a route in the routing table like this, right? And for tunnel.1 also you should add an IP address. When you add an IP address, one more route will get added in the routing table saying for 10.1 send via tunnel.1, right? As how we did in the head office, let us do the same thing in the branch office firewall. So now I go to the lab side, I go to the branch office firewall here. I go to network. Under network, I go to interfaces. There I go to what? Tunnel interface. I'm creating one tunnel interface. Where did I go for this? I'm going to what? Under network, interfaces, tunnel interface. I say what? Add. I'm adding a new tunnel interface. I say add. I give the name of tunnel interface as what? Tunnel.1. And I assign it to the virtual router called as VR1 and security zone called as what? External, as shown in the diagram. And I give the IP address as 10.1.0.2, 10.1.0.2/16, right? I say okay, right? Now again, I go to the static routes. So I go to virtual routers. I go to VR1 router. I go to static routes. There I add 3 static routes. I say add. One static route I add for 192.168.11.0. I say for 192.168.11.0/24. Send the packet via the interface. Via which interface now? Tunnel.1 interface. And next stop I don't mention, I say none. So I'm adding a route saying that for 11.0 send via tunnel.1 interface. I say okay. Similarly, add one more route saying for 192.168.12.0, for 192.168.12.0/24, send the packet via tunnel.1 interface. Next stop is what? I say none. Right? I say okay. Again, add one more route saying for 192.168.13.0, for 192.168.13.0/24, send the packet via which interface? Tunnel.1 interface. Next stop is what? None. So I'm adding these routes in the routing table of the firewall. So now if I say commit, and if I try to see the routing table of BO firewall, branch office firewall, I go to branch office firewall. I say admin, I say capital P at the rate of SSW0RD, I log in. There I give the command show routing route. Show routing. Show me the routing table, right? Show routing route. It shows it shows like this. See the diagram now, I should see all the 4 routes, right? I should see one route via tunnel because it's what? Directly connected. I'd also see this for the 3 routes, right? For 11.0 send via tunnel.1, 11, 12, 13 send via tunnel.1 interface, right? How do I do that now? If you see the case study diagram, it has route saying for 10.1.0.0 connected, send via tunnel.1. For 11.0, 12.0, 13.0, send via whom now? Tunnel.1 interface. So these routes get added in the routing table like this. Again, I go to the firewall, branch office firewall. Now I create the tunnel. I go to GRE tunnel. Where did I go? Under network, I'm going to what? GRE tunnels. I'm creating one GRE tunnel saying what? Add. Saying, I say name BO-2-HO. Interface, I choose what? Ethernet 1/2. Whose address is, what is the source address now? 40.2. What's the peer IP address? 20.0.0.1. And what is the which interface I choose now? Tunnel.1 interface. So what do you mean by this particular dialog box? It says when the packets are leaving via tunnel.1 interface, add one more IP cover. In the new IP cover, add the source IP address as 40.2. The destination 2 IP address as what? 20.2. That's what we mean by this. If you see the diagram here, when the packets are leaving via tunnel.1, add one more IP cover. The new IP, add the source address as what? 40.2, your own IP. IP address Ethernet 1/2, which is 40.2. The 2 address should be what? 20.1, PS IP address. PS IP address, right? So that's what we mean. Sending via tunnel.1 means add one more IP cover. The new IP cover, add the source address as 40.2, 2 address as what? 20.1. Now I say okay. Now I say what? Commit the changes. I say commit. I also go to the firewall. I say add a new security policy saying add. I give a policy in that policy P1. I say when the packets are going from internal or external zones, go into internal or external zones, right? Send for any application, any service, allow the packets to go, right? Add a security policy like this. Now I say what? Commit. I say what? Commit the change. Now I go to again HO firewall. I give the command show interface tunnel.1. Enter. It shows what? When I give the command show interface tunnel.1, it shows it is a layer 3 interface because you can give an IP address attached to what? VR1 router. Which particular zone it is attached to? External zone. And when the packets are leaving via this tunnel.1, source address will be what? 40.0.0.2. 2 address will be what? 20.0.0.1. This command I gave on branch office firewall, right? Can also verify the tunnel like this. So I go to the head office. I go to head office. Remove the previous one in editing now. I go to head office. I give the command show interface tunnel.1. I say enter. It shows clearly when you give the command show interface. So remove that also in editing. Show interface tunnel.1. It shows when the packets are leaving via tunnel.1, right? It shows. show interface tunnel.1 is the command I gave on head office firewall. It shows that tunnel.1 IP address is, it's a layer 3 interface. It has got an IP address and attached to what? VR1 router, virtual router VR1 belongs to which particular zone? External zone. What is IP address? 10.1.0.1/16. When the packets are leaving via tunnel.1, a new cover is added. In a new cover, source address will be 20.1. To address will be what? 40.0.0.2. IP address of the branch office firewall. Similarly, I also go to the branch office 1 firewall, BO firewall. There also I give the command show interface tunnel.1. It shows that tunnel.1, right, is what? Again, layer 3 attached to VR1 router, belongs to which particular zone? External zone. IP address 10.1.0.2/16. And it says when the packets are leaving via tunnel.1, add a new cover. The new cover local source address is 40.2. To address is what? 20.0.0.1. So like we can verify the tunnel interfaces on the head office and branch office firewalls. Now let us see what happens when the packets go. Now I go to the diagram again. Now we have seen the routing tables of HO firewall, ISP router, ISP R2 router, and also branch office firewall. Now let us see, if somebody is sitting on this port 11.10, they give the command ping 192.21.10. What happens now? A packet will be created where the source address is 192.168.11.10. To address will be 192.168.21.10. Source IP to IP. When the packet comes to the firewall here, what happens on the firewall? The IP protocol sees the two IP address. What's the two address? 192.168.21.10. So the packet has to go to whom now? .10 system located in 192.168.21. area. So IP sees the routing table. To see route is available for this network. Route is available saying for so-and-so area, send via tunnel.1. Send via tunnel.1 means what? Add one more IP cover. So one more IP cover will be added on this particular packet. So IP protocol adds one more IP cover. In the new IP cover, what should be the source IP address? We said source address is what? 20.1, your own IP address. To address is what? 40.2. So source address will be 20.1. To address is what? 40.2, the PS IP address. So those two parameters will be added over there, right? Now what happens? Again, IP protocol is again the new IP cover. Again, IP has to do routing for what? The new IP address, right? Again, this is the new IP cover. What's the two address over there now? 40.0.0.2. Now the packet has to go to whom now? .2 host belonging to what? 40.0.0 area, right? Again, IP is the routing table. Is a route available for 40 area? No, no specific route. Which route will be applied now? The default route. And default route says any net minima simply pass on the packet to whom? 20.2. So the packet will be sent to whom now? IP protocol forwards the packet to whom? ISP R1 route, right? Again, the IP protocol running on ISP R1 sees the two address. It sees only the outer cover, right? In outer cover, what's the two IP address? 40.2. It says routing table. Route is available for 40. Says what? Send the packet home now. 30.2. This particular route will be applied. And IP protocol again forwards the packet. To whom? To ISP R2 router. Again, the IP protocol running on ISP R2 again sees the two address. What's the two address now? 40.2. Again sees routing table. Route is available 40 network ID. It has to forward the packet. What happens? IP protocol forwards, applying this particular route, IP will forward the packet, right? Forwards packet to whom now? The firewall. What happens on the firewall? The IP protocol running on the firewall will see the two IP address. What's the two address over there? 40.0.2. Whose address is it? Its own IP address. So IP processor 2 address is what? Its own IP address. It's meant for whom? Meant for this particular firewall only. So it removes IP cover. When it removes outer IP cover, the inner IP cover will come out now. Again, IPs is a 2 IP address. What's the address over there? 192.168.21.10. So again, what does IP protocol do? IP has to forward the packet. IP routing table. Route is there saying that for so-and-so 21.0, send the packet whom now? 24.1. Applying this particular route, IP again forwards the packet. The packet goes to layer 3 switch. It again sent to whom now? This particular system, right? So that's how the packet goes from system in the head office to systems in the branch office. Means what? Now all the systems in the head office here should communicate with whom? All the systems in the branch office, because the firewalls are adding what? They add one more IP cover. In the new IP cover, they add what? Two addresses as the public IP address, right? We have seen all that. Now let us see this. So let us verify. Now I go to the activities. I go to head office system 10. Mango HO system. I give the command show IP. What is IP address? 192.168.111.10. So I'm on this particular system. If you see the diagram here, I'm on the head office system, right? From there, I give the command ping 21.10. So now I go here. I say ping 192.168.21.10. The system in the head branch office one, I should get the reply, right? Everything is fine, I should get the reply. That's taken some time. Now again, I say up arrow, again enter, I get the reply, right? So the head of system, head office is able to commit systems in the branch office. Again, I say 22.10. Also, I should get the reply. Even if I say ping 23.10, also I should get the reply, right? So 23.10 also I get the reply. So from head office, I'm able to ping all the systems in the branch office, 21, 22, 23. Similarly, even if I go to the system in the branch office, BO system, I give the command show IP. What is the IP address? 21.10. From there, I say ping 192.168.11.10. I get the reply. Even if I say ping 12.10, also I get the reply. Even if I say ping 13.10, also I get the reply. So all the system head office, which are on the private network ID, are able to access systems in the branch office because the head office and branch are adding a new IP count, right? The systems in the private network ID in the head office are able to communicate with systems in the private network in the branch office through the public network, because the firewall is adding a new one more IP cover. In that, it has what? The routable public IP addresses. That's why they're able to talk to each other, right? So this is how we configure GRE tunnels on the Palo Alto Firewall.